This video will show you a graphic organizer that will help you as you navigate working with percents. Be sure to have the date and topic at the top. The essential question is, how can we remember how to perform operations on percents? So far we have learned 3 different ways to talk about percents. We have talked about finding the value when we know the percent and the whole. We've also found the whole when we know the percent and the part. And lastly, we can find the percent when we know the part and the whole. All 3 of these are equally important and valuable for us to understand, but it can be confusing knowing when to use the various operations to solve each type of problem. Luckily, I have a little graphic organizer that should help you remember. I'm going to go ahead and load that up on the next page. You'll want to draw this into your journal. Here we have a nice little triangle that shows us all the different aspects of finding a percent. So we have some information when we know the part, when we know the whole, and when we know the percent. And it also shows us operations that can be used to help calculate one of the items when you know 2 out of 3 of these parts. Make sure you have this recorded in your journal. We're going to see that while this picture is really great, it's not enough to know exactly what to do. But combined with the work that we have already done, right, this can be a great way to just remember the process and which process works in which situation. We'll take a look at each of the 3 processes as we go forward. So here we have a question. It says 36 people were on the Selwood corridor over by Oaks Park. 20 were on bike. The question is, what percent were on bike? So we're going to break this down and figure out what we know and what we need to find out. It looks like here we know the part, right? This is the part who were on bike, and the whole, all of the people who were there. So we seem to know the part and the whole. Right? Looking at my organizer, that reminds me that if I know the part and the whole, I need to be dividing. Right? And of course, now I remember that that means I have the part over the whole. So I'm going to set this up as 20 over 36, and I'll use that to set up my long division, 20 over 36, 20 divided by 36. To complete this, of course, I would need to go through my long division process. You can take a moment to do that as well yourself, right? And we're going to see what percent are on bicycle. In this instance, I see pretty quickly that I have a decimal in the 5 that keeps repeating, right? So I have my decimal here, but I remember that that's not quite my final answer. I'm looking for a percent. So I'm going to multiply this by 100, which means move my decimal over twice, and it's 55, and I'm just going to round this up here, 55 and 6/100ths of a percent. So about 56% of the people were on bike. So the triangle alone maybe wasn't enough for me to know exactly what to do, but it helped me remember which of my steps I needed to solve this type of problem. We'll try another question. The next question says 20 people were on bikes. 10% of those were not wearing helmets. The question then is, how many people were not wearing helmets? So let's take a look at what we know and what we need to know. This time it looks like we know the whole. We know all the people who were on bikes, and we know the percent of those that were not wearing helmets. So it looks like in this case we know the whole and we know the percent. We're trying to find the part. We're trying to find the number of people who were biking but were not wearing helmets. Right? This quick look tells me that I need to multiply to find this out. Right? So that reminds me that I'm finding 10% of 20, and that is a multiplication question, right? That's what this is a good reminder of. So of course, to do that, we turn this into our decimal, and we multiply. And we find that the answer is 2, right? 2 people, that's the part of the group, were not wearing helmets. We have one last type of situation. In our third question, we see that 20% of the walkers on the corridor were walking their dogs. There were 3 people walking their dogs. The question is, how many walkers were there? So this one, it's pretty obvious that we have the percent, right? So we know we're looking at the percent here. And then it says there were 3 people walking their dogs, but we're trying to figure out how many people were walking all together. So this 3 represents the part, right? What we're trying to find out is the whole. So looking at my graphic reminds me that this is a division question, right? This is one of our backtracking when we had to divide. We knew that we were looking for the number of people who had a dog. We know that if we took 20% of that number, we would end up with 3, right? So we know this is a backtracking division question, and that's there in my graphic as well. So now I can look at that and say, oh, right, I remember. I'm supposed to divide 3 by my 20%. Right? So of course I would just go ahead and set this up. You can set it up as well. I remember that I have to move my decimal. I'd have to move a decimal here, the same number of spaces. Add a couple place-holding zeros. And I would see that my answer is 15, right? There are 15 walkers. And I found that out through backtracking, and I remembered that it was backtracking by looking up here at my graphic and seeing that, oh, right, it's a division question. This visual is a great way just to remind ourselves of the work that we have done with our percents so far. Feel free to draw this reminder anytime that you need to refresh yourself on percents. Right? The essential question of this video is just to see a strategy to help us remember all of the different ways that we work with percents.